Now, any parameterized surface S that's represented by z equals g of xy, I'm sorry, any non-parameterized surface, just simply z equals some function of xy, can be parameterized. And we can quickly and easily parameterize it simply by saying that x is going to be equal to x, y is going to be equal to y, and of course z is going to be equal to the function g of xy. So that's really not cheating. It's just kind of, in a way, stating the obvious. Therefore, I can go ahead and parameterize it in terms of a vector function, r of xy. This is going to be the vector x, y, g of xy, which, remember, this is just z. So that would then imply that the partial with respect to x is going to be 1, 0, the partial of g with respect to x of xy, and obviously the partial with respect to y is going to then be 0, 1, the partial of g with respect to y. So from that, I can go ahead and I'm thinking about doing the surface integral. So I know I'm going to need this cross product, rx cross ry, which again is a determinant I, j, k, 1, 0, partial of g with respect to x, 0, 1, partial of g with respect to y. So I'm going to have 0 minus the partial of g with respect to xi minus partial of g with respect to y minus 0, j, plus 1 times 1 is 1 minus 0. This is just going to be k. That gives me this vector that looks like this. So the magnitude of the cross product is going to be the square root of the partial of g squared plus the partial of y squared plus 1. Which, remember, though, that g, actually z, equals g of xy. So I could rewrite this as being the partial of z with respect to x squared plus the partial of z with respect to y squared plus 1. Therefore, the integral over the surface of f of x, y, z ds is equal to the integral, the double integral over the domain of f of x, y, g of xy, because remember this is in fact z, times the square root of the partial of z with respect to x squared plus the partial of z with respect to y squared plus 1 dA. Now note here if f of x, y, g of xy, which is f of x, y, z, equals 1, then we have the surface area of S. We'd just be integrating this, which should look pretty familiar to you. I'll write that out real quick. Of 1 ds equals the double integral over the parameter domain of the square root partial of z with respect to x squared plus the partial of z with respect to y squared plus 1 dA, which is equal to the surface area.